Okay, this is 12175. It's just the very next one in the 11th edition. Okay, it's exactly the same setup. I like this type of problem because it's the same setup, but then it asks different types of problems, different questions. Okay, exactly the same setup as the previous video. That's actually what I should say, the previous video. Maybe you didn't watch the previous video. This is exactly the same setup as the previous video, but it's a different question. So determine the time needed, time now, for the load at B to attain a speed of 8 meters per second, starting from rest. Oh, what does that mean? If the cable is drawn, that's the cable, is drawn into the motor with an acceleration of 0.2. So here we're going to say the acceleration of point A is 0.2 meters per second squared, and we know that it should be positive because it said it should go to the right. So if you recall, this was the previous problem, so it's very messy. Ignore all the mess and just focus on SB and SA. Remember how we defined our positions of the 2 points of motion? SA was down from the datum. It was positive down to the pulley. Sorry, did I say SA? SB from the datum down positive, from the datum to the right positive SA. And we got this relationship. SA equals 4SB, VA equals 4VB. And so from this, we know we should get acceleration of A plus 4 times acceleration of B equals 0. So we should just follow this, and that's what we should get. The acceleration ratio should stay the same. So let's do it here. No, let's do it here. Acceleration of A plus 4 acceleration B is 0. Okay? So let's solve for AB, and you'll see why. AB is minus, let's just see, am I doing this correctly? Minus a quarter AA. All right, so, okay, don't just follow what I'm doing. Please try this problem on your own and try to think it through. Try to get the solution. Actually, you should pause the video now and try to solve it on your own, okay? But what are we trying to do? We have the acceleration at point A. That's what we're given. But we're trying to find the time it takes for the velocity of B to reach 8 meters per second. Okay? So with the other problems, remember the other problems, ignore all this stuff, just ignore it. I'm just using this to write. With the other problems, remember we started at positions, and we went to velocity, and we went to acceleration. Now, we're starting essentially at acceleration, and now we need to go back to get a velocity relationship. So we know that our acceleration relationship is given by this, right? We got it from there. So let's calculate now our acceleration of B, because remember, we're trying to find the velocity, the time it takes for this block B to reach 8 meters per second. So if we're only given acceleration information, and we're given the acceleration of A, let's see what the acceleration of B is and see if we can relate it to the velocity of B. So the acceleration of B is minus a quarter, and what is the acceleration of A? It's 0.2, and so acceleration of B is minus 0.05 meters per second squared. Okay, so that is a acceleration of block B. What do you notice about it? It is constant. Acceleration of B is minus 0.05 meters per second squared. It is constant. And we're looking for the time it takes for this block, starting from rest, to reach 8 meters per second. Do you recall this equation? This is, you can only use this for constant acceleration problems. So, we want the final velocity to be what? 8. What is our initial? What is it? What is it? 0. What is our acceleration for B? Acceleration for B is minus 0.05. Minus 0.05 times t. Okay, v equals v0 plus a t, acceleration of b, times time. Okay, so the final velocity is 8. Okay. Have I made a mistake here? I was just working this out and I see I've made a mistake. Can you notice where I've made the mistake? I hope you did. We want this to go up with a velocity of 8. So that needs to be minus 8. Okay? I hope you're picking this up. Remember, down is positive, up is negative. Down is a positive position, down is positive velocity, positive acceleration. Up for this particle, up is negative. So we have minus 8, because the final velocity must be 8 upwards, is equal to 0 initial velocity, and the acceleration is minus 0.05, because the acceleration is up, times time. So if we calculate the time here, it will be 160 seconds. So it's going to take 160 seconds for block B to reach 8 meters per second. Okay? So again, we started with our acceleration. We needed the relationship between that acceleration and that acceleration. We got that from this initial position relationship, the total length. Okay? We differentiated that. We got our velocity relationship. We differentiated that. We got our acceleration. So I took this, I wrote it down there, I solved for B because that's what we're looking for, the velocity of B. So I needed the B information, acceleration of B. I calculated that. I saw, oh, it's constant. Oh, I know what to do when it's constant. I can use one of these equations. I'm looking for the time. I used this one, I calculated that. Good luck, guys. Cheers.